Hello everyone and welcome to our channel DevOps. So in today's session, we will learn how to create MySQL RDS database instance with Terraform. So these are the table of contents which we are going to learn today. So let us start. What is Terraform? So it is an open source infrastructure as a code software tool where you define and create resources using providers in the declarative configuration language, example JSON. With Terraform, you can package and reuse the code in the form of modules. It supports number of cloud infrastructure providers such as AWS, Azure, IBM Cloud, and etc. Now let us understand about what is Amazon Relational Database Service. So RDS stands for Relational Database Service. It is managed database service for database use and it uses SQL as a query language. It also It allows you to create databases in the cloud that are managed by AWS, like Postgres, MySQL, Oracle, Microsoft SQL Server. So it is a web service that make it easier to set up, operate, and scale relational database in the AWS cloud. By using RDS, it provides cost-efficient, resizable capacity for an industry standard where relational database and manages common database administration tasks. What are the advantages over using RDS versus deploying a DB on EC2 instance? First is automated provisioning and OS patching. For example, when you choose RDS, you don't need to manually set up the database server or worry about operating system updates. RDS handles the provisioning and patching of the underlying infrastructure for you. If a security update is released for the database engine, RDS can automatically apply it during the maintenance window without manual intervention. Next is continuous backups and restore to specific timestamp. For example, RDS automatically takes regular backups for your database. Let's say you accidentally delete some critical data. With RDS, you can perform a point in time restore to revert your database to a specific timestamp before the deletion occurred. This provides a reliable way to recover from data loss scenario. Next is monitoring dashboard. So RDS provides built-in monitoring dashboard that offer insights into the performance of your database, which you can use to easily track metrics like CPU utilization, storage usage, and input-output activity. Next is RAID replicas for improved read performance. Suppose your application experiences high RAID traffic. With RDS, you can create and read replicas of your primary database. So these replicas handle RAID queries, distributing the RAID workload and improving overall performance. Multi-availability zone for disaster recovery. In this event of a consider an event where you have a hardware failure or other issues affecting the primary database. So RDS can automatically fail over to a standby replica in a different availability zone. This ensures high availability and provide a level of disaster recovery without manual intervention. Next is maintenance windows for upgrades. So when there are updates or maintenance tasks, RDS allows you to set maintenance windows during non-critical hours. This ensures that updates are applied at a time that minimizes impact on your application. Next is scaling capability, vertical and horizontal. So as your application grows, you might need to scale your database. With RDS, you can vertically scale by choosing a larger instance type to handle increased resource requirement. Additionally, RDS also supports horizontal scaling by allowing you to create read replicas or sharing your data across multiple database instances. Storage backed by EBS. So RDS provides scalable and durable storage backed by Amazon Elastic Block Store. So you can choose different type of storage like general purpose SSD and provision. Based on your performance and throughput requirements, this flexibility allows you to tailor storage to your application's need. So this is the basic architecture of RDS. So as you can see, first is elastic load balance. So it is a setup to distribute incoming web requests across the three instances, which helps to balance the load, ensuring that each EC2 instance receives a fair share of incoming traffic. So the web request flow is done when a user makes a web request. So it is directed to elastic load balancer and then move forward to the EC2 in the auto scaling group. So the EC2 instance process the request and interact with the MySQL database hosted on Amazon RDS instance for read and write operation. So for read operations, the EC2 instance retrieve data from the MySQL database in the RDS instance. For write operations, the EC2 instances send data to MySQL database to update or insert new record. So now we will start with the implementation. Before that, you need to install Visual Studio Code and the extension provided by the HashiCorp company for Terraform. So let's begin. So first step is to create infrastructure for this project in Visual Studio Code. So let's create the following organization structure. So first, you need to create a folder named Terraform RDS project, and you need to create four files: main.tf, output.tf, terraform.tf parse, and variables.tf. So we will create first variable.tf file in our folder. So variable.tf file is used to declare the variables in Terraform. So variables allow you to parameterize your configuration, making them more flexible and reusable. So we have mentioned here three variables named access key, secret key, and the region. And this is the description. We have written the attributes. So the code defines three variables: access key, secret key, and region. So variables in Terraform, as we know, used to parameterize the configuration. So they allow you to input values when running the Terraform command. So each variable have an attribute. Description attribute which provides a human readable description of the purpose of the variable. So it serves as documentation for users that will provide values for the variables. So these variables might be used in other parts of your Terraform configuration. For example, they could be used to configure the AWS provider block to authenticate AWS using the provided access key and secret key and set the AWS region. Next, we have created terraform.tf vars file where this file is used to set values for the variables declared in variable.tf. So it allows you to provide specific values for your variables without modifying the main Terraform configuration files. So the first line assigns the value for the region. The second line assigns the variable named access key, where you need to mention your access key ID. And in third, you need to mention your secret key ID. So the secret key ID is used for the authentication with AWS. So user typically create terraform.tfr file to store the sensitive information like access and secret keys. So this separation allows you to keep your sensitive information out of the main Terraform configuration files and make it easier to manage different configuration for different environments. Now next, we will create one main.tf file. So this is used for the Terraform configuration file where we define the infrastructure, resources, and the configurations. So it specifies what resource you need to create, how we can configure them, and we can also write any necessary settings in main.tf file. So the first block of code configures the AWS provider for Terraform. So it specifies the region, access key, secret keys using variables defined in the variables.tf file. Next, we will create a security group for RDS database instance. So we can refer this block of code from the official website of Terraform. So let's see. Type Terraform registry on the search bar and click on providers. We are currently using AWS. So click on AWS and then click on documentation. Then find the resource name. So currently we need security group. So as you can see, copy this code and paste it in the main.tf file. So this is just for the reference. Now move on to next. So with this block of code, first I have taken the resource name which is AWS security group and named the instance as RDS SG. So what it does? So it allows the incoming traffic on port 3306, which is the default port for MySQL from any IP address, which will effectively make the database accessible from anywhere. Next, in this block, it allows the outgoing traffic from the RDS instance. Now we will create a RDS database instance. You can also refer this code from Terraform registry. So let's check. So as you can see, AWS DB instance. So copy this code and you can edit this code in your main.tf file. So now let us understand this code. So to create a RDS database instance, we need to type the resource name of AWS DB instance, and we have taken the name of that instance as my instance. Next, we have specified the engine name, which is MySQL. And next, we have given my RDS instance name to the identifier, and the allocated storage is 20 GB. So it uses MySQL engine and set the identifier to my RDS instance and allocates 20 GB of storage. Next is the instance class. And this is the engine version. The next is the instance class, which we have mentioned db.t2.micro. This instance class db.t2.micro is for free tier. Next, we will specify the username, which I have taken as admin, and password is admin12345. And parameter group name is by default MySQL and the engine version. Next, VPC security group IDs. So it associates the previously created security group ID with the RDS instance. So skip final short. So this attribute is set to true, which means no final DB snapshot will be created when RDS instance is deleted. Publicly accessible, which is set to true, so allowing the RDS instance to be accessed over the internet. So when we enter this configuration and if we enter the Terraform apply, so it will create an RDS instance with a specified parameter and a security group allowing MySQL traffic. So as we have mentioned the VPC security group ID, now create an output.tf file. So this output.tf file is used to define output values that you want to be shown when Terraform applies your configuration. The outputs can be useful for obtaining information about the infrastructure that you can use in subsequent steps for display purpose. So the first block of code defines output name as security group ID. So the value assigned to this output is the ID of the AWS security group created earlier for the RDS database instance, which we have created here. So this output can be useful if you want to reference the security group ID in other parts of your infrastructure or script. Next, next we will define an output named as DB instance endpoint. So the value assigned to this output is the endpoint of the RDS database instance. So the database instance endpoint is the DNS address to connect to the database. So this output is valuable if you need to use the database endpoint in other parts of your infrastructure or application. So when you will run Terraform apply, so Terraform will create or modify a AWS resources according to the configuration which are stored in main.tf file. And after the execution, it will display this output. So now we will open the terminal and execute our Terraform commands. So open an integrated terminal. So type Terraform init command. So as you can see, it is initializing the provider plugin. So this command initialize your Terraform working directory, it downloads the necessary provider plugins and set up the backend. So as you can see, Terraform has been successfully initialized. Next, we will clear the screen. Now, we will type Terraform plan command. So Terraform plan will show the changes that will apply to the infrastructure, and it will show the additions and the modification. So as you can see, it plan 2 to add, 0 to change, and 0 to destroy. So as you can see, it is adding our RDS DB instance and the security groups will be created after we type Terraform apply. So now clear the screen, type Terraform apply. So Terraform apply is a Terraform command that executes the planned changes for creating, modifying, or deleting resources to align the actual infrastructure with the desired state defined in our main configuration. After typing Terraform apply, press enter. So as you can see, terraform.tf state file is been loaded. Enter a value, type yes. So as you can see, AWS security is creating and AWS DB instance is also being created. So after creation of this instance, we will check this on our AWS console. So as you can see, it have taken 3 minutes 57 seconds, which is approx 4 minutes it takes to create database instance. So as we can see, apply is complete and two resource has been added successfully. And we have mentioned the output which we want is security group ID and database instance endpoint. Now we will clear this and we will check if our RDS instance has been created or not in the AWS console. So let's check. So search RDS here and click on the first option RDS. In the left hand side corner, click on databases. So as you can see, my RDS instance has been created successfully, which is showing the details of status, role, engine, the region, and the size, which I have mentioned in our main.tf file. So click on my RDS instance. So this is the summary of the instance. You can see more options, monitoring, log and events, configuration, maintenance and backups, and tag. Now next, if we want to monitor the progress, so we will use the command terraform show. So it will display the execution plan and ask for the confirmation before applying the changes. So once confirmed, it will create MySQL RDS instance. So we can monitor the progress in our AWS management console or by simply typing terraform show command. So it will show our main.tf file and the security group which we have created. So now we will clear this and now we will check that if our configuration file is valid or not. So to check this, we will simply type terraform validate. Enter. So as you can see, success. So this configuration is valid. Now, if we want to automatically format the Terraform configuration file and ensure consistent and readable code, so it is done by applying a standard style, and for that purpose, we use Terraform format command. So just type Terraform fmt command and press enter. Now clear this. Now we have performed a practical successful. So the Terraform fmt command will show our 4 files created. Let's type again. So it is not showing, but let it be. So the output will be this. It will show our main.tf file, output.tf, terraform.tf vars, and variable.tf file. So as we have seen the end result in the AWS console, so we will conclude for today. So for reference, as I have mentioned in this video, we can visit the official website of Terraform registry, which is Terraform registry. And if you have any queries, please contact us. Thank you for watching. And if you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more content. Feel free to leave your thoughts or suggestions in the comments below. See you in the next video. Thank you.